Hello and good day, geometry. That was horrible. Welcome to CO14, our last rule that we're going to talk about. So PO15 is kind of the culmination of all the rules. We combine them all together. You might be dividing by the same base with negative powers while you're distributing into a zero. It's a lot of fun. But one rule to cover before that, and that is the distributive property with exponents. We've done the distributive property before. If you think back to algebra, pre-algebra, if you've got a coefficient on the outside of parentheses, you distribute it into the parentheses, right? And what do we kind of define the word distribute to mean? In that sense, right? Like where you've seen this before is if we had something like -2 and then x plus 7, right? And you would distribute that into the parentheses to simplify it and get rid of them. So what does the word distribute mean in a mathematical sense? Yes, in the back. Perfect. Good job. To distribute means to give to every term in the parentheses. Okay, and since we are talking about powers here, it might be more appropriate to say to give to every base in the parentheses. Whatever exponent is on the outside of our parentheses, it's being distributed into every base. Okay. So that first one there, where it's 4n in parentheses, what is the base of that power of 2? What is the base of that power? What's getting squared, Will? N, and because it's in parentheses, the 4, right? So what we're going to do, writing this out in expanded form here, is, green works today. That's fantastic. In expanded form, we have 4n times 4n, right? Both are being squared because of those parentheses. We can rewrite this to say 4 times 4 times n, because when we multiply, we can write things in any order we want to. It doesn't affect it. So we can group our 4s together, group our n's together, okay? And we know that 4 times 4 is 16, right? But for the interest of this objective, I'm going to write that as 4 squared n squared. 4 squared n squared. And we'll come back to why that is in a little bit. Okay? Number 2, what's being cubed? What's being cubed? Again, pay attention to those parentheses. Yes, Blake? 5x. Right, the whole thing, right? So we've got 5, we got 5xy squared times another 5xy squared times another 5xy squared. Again, we're starting with expanded form so that you can hopefully see mathematically what's kind of going on behind the scenes here. There is a shortcut for this, thank goodness, right? But first we want to kind of see what's going on. I can rearrange this since we're multiplying to put my 5s together. So 5 times 5 times 5 times x times x times x, group my bases, times y squared times y squared times y squared. Okay? I just kind of grouped everything together. I grouped up my 5s and then my bases of x and my bases of y. And even though you might know that 5 times 5 times 5 is 125, for the purpose of this, I'm going to write it as 5 cubed. Okay? And then what's x times x times x? Using a power. X times x times x. X cubed. And what's y squared times y squared times y squared? Y to the 6th. Okay? As we're going through this, take a look and see if you can pick up on what the shortcut is. How do we get from our original expression to our simplified expression. How did I get from here down to here? Right? Because that's ultimately what we're going to be doing, is we're going to be looking at the rule for this. The last one, number 3. Oh boy, here we go. Okay, we've got exponents inside parentheses and exponent outside of the parentheses. I want to focus on this power of 2 right here. What's getting squared? Peter?
5n squared over 4t cubed.
Right. 5n squared over 4t cubed times 5n squared over 4t cubed. 5n squared over 4t cubed times 5n squared over 4t cubed. Everything inside of the parentheses is getting squared. So for starters, what do you see as a similarity between all 3 of these? That's kind of a hint that, oh, okay, I'm going to be needing to distribute here. What do all 3 of these examples have? And probably most, if not all, of the examples on your page that you're going to be doing in homework here. Blake? I'm not talking about the shortcut. I'm not, but what do all 3 of these have in common? The original expressions. What do they all have in common? Yes, kid in the back again. Excellent. These are parentheses, right? They all have parentheses, okay? When you see parentheses, be thinking distributive property, right? Just like when you see a negative power, obviously you're using the negative power rule. When you see a 0 power, obviously you're using that rule. When you see parentheses, be thinking of distributing. So what does this equal? 5n squared times 5n squared. I'm going to group my 5s together to give me 5 squared. And n to the what? 4th. My denominator, I've got 4 times 4, which I'm going to write as 4 squared for the purpose of this. And then what's my exponent on my t? T to the what? The 6th. Okay. All right. Who's ready to tell us what the shortcut is, what the rule is, so we don't have to go to expanded form when distributing? Blake, you were all set for before. What do you got? Okay, so for starters, if you have an exponent already, they get multiplied, right? Where we see that here is with this 3 times 2. We already had a square, a power of 2 on our base of y. So when we distribute that 3 in there, we're going to multiply 2 times 3. That gave us the 6 here. Okay? We see it again in the third example. We have a 2 times 2, which could also be the same thing as 2 plus 2, but definitely this 2 times 3 here, we already had an exponent on our base of t, and so when we distribute that 2 in, we're going to multiply, and we get t to the 6th here. So exponents are multiplied. Okay? We have a rule where exponents are added. We have a rule where exponents are subtracted. We now have a rule where exponents are multiplied. So it's important to be able to recognize what rule are you using, right? What situation are you using so you can do the right thing. How about a coefficient base? And by coefficient base, I'm talking about, in this case, the 4 here, in this case, the 5 here, and the 5 and the 4 here. I like 5s and 4s, apparently. Okay. What happened with that coefficient base? Gino?
Exponent on the outside to the end of it.
Right. It takes on the power. Okay? It takes on the power. 4 in this first one became 4 squared. 5 became 5 cubed. 5 became 5 squared, and 4 became 4 squared. Great game, by the way. Yeah. Huh? What'd you say? What? I thought you said great game because I said four squared. Like 4 squared, the game? 4 squared? No? What did you say?
You said
Oh.
you tried to say before, like you stumble and you said became or something.
Oh, he was mocking me? Oh.
No. Okay. You say mocking. It sounds bad.
It does sound bad because it is bad. Yeah. Some things sound the way they are. Like sizzle. Sizzle sounds like sizzling. Mocking sounds bad because it is. This class took a bit of a turn. Too bad I don't know how to edit. Okay. How about our variable base here? Okay. And one more thing I want to add here for the coefficient, it takes on the power. And if we wanted to, right, we could write that 5 squared n to the fourth as 25 n to the fourth. And if we wanted to, we could write that 4 squared t to the sixth as 16 t to the sixth. Okay, so the coefficient base can change if you decide to actually multiply it out. Right? It has the potential. When it takes on that power, if it's a number, it has the potential to change if you multiply it out. A variable base, on the other hand, we'll do that in black. We haven't used black yet. A variable base, this n just became n squared. This x became x cubed. The y squared, we already talked about that, but our base here is still y, but the power changed. Here, our n squared remained an n, even though the power changed. Our t remained a t, even though the power changed. What can you tell me about a variable base? Like everything I just underlined there in black. Gino? Very good. The variable base also takes on the power, but this one does not change. Okay, it remains a variable, just as every other rule we've seen so far, with the exception of the zero power property, because that does change the base. But the point is, everything inside of the parentheses gets the exponent. Okay, what happens kind of depends on whether it's a coefficient, a variable, or if it has a power already, but everything gets it. Questions on this? You now have more math power than ever before. Get it? Because we're doing powers. It sounded better in my head. All right, let's do some practice here. Okay. Again, notice that all of these have parentheses. Some of them even have negative exponents. Some have negative bases. For this one, I'm asking you to write it in expanded form. Okay. And if you can, simplify within the parentheses first. That's going to generally make your life a little bit easier. Okay. So 3n cubed in expanded form, I'll even do it with you. 3n cubed, what's being cubed is everything inside of the parentheses. This is equal to 3n times 3n times 3n. The parentheses make both the coefficient and the n part of the base, and we're cubing it. And so what we get is 3 cubed n cubed. If you want to write that as 27 n cubed, you can. But again, notice here, distributing that 3 in, the coefficient base takes on the power, 3 cubed. We could change if we wanted to. The variable base takes on the power, does not change, n cubed. Okay. The next one, 2x squared y cubed times 2x squared y cubed times 2x squared y cubed times 2x squared y cubed. Okay. Putting it all together, we have 4 2's. We can write that as 2 to the fourth or 16. Either one's fine. We have a total of 8 x's here, 2, 4, 6, 8. And we have a total of 12 y's, 3, 6, 9, 12. Comparing this answer to our rule, the 2 gets the 4, becomes 2 to the 4th. The x squared gets the 4. It already has a power, so we multiply it to get x to the 8th. The y cubed gets the 4. It already has a power, so we multiply 3 times 4 to get 12. Okay? The third one here is where people start to get a little bit tripped up, okay? And where expanded form is helpful, right? The most common incorrect answer here would be negative 16 or negative 4 squared, either way you want to write it, n to the 6th. Why is that incorrect, and how can we use expanded form to prove it? Yeah, Joey.
Negative times a negative is a positive.
Right, that negative sign being inside of those parentheses. When we put this in expanded form, what's being squared? Negative 4n cubed times negative 4n cubed. And negative 4 times negative 4 is a positive 16, not negative. If we wanted to write it as negative 4 squared, because remember we said that when you distribute this power, that could change. You could write it as 16, but if we wanted to keep it as negative 4 squared, what do we have to have? Parentheses. We have to keep the parentheses around the negative 4. Right? Because negative 4 squared, negative 4 times negative 4 is positive 16. And then n to the 6th. Okay. Let's look at, the next one, a negative power here. Do we have to distribute first, or could we take care of that negative exponent first? Does it matter? No. What do you want to do? Audrey, negative power first or distribute first? Just pick one. The power first. Wait, which one? The negative power or distribute the power? Just say negative or distribute, or even n or d. Fine. Okay. So taking care of that negative power first means that we're still going to have this inside of parentheses, but how can we rewrite that? 15x to the negative second, how does that rewrite? Joey?
It'd be 15 over x.
Right. Remember, a negative power, you move the exponent and its base to the other part of the fraction, make the power positive. Okay? So now when we distribute, 15 squared over x to the 4th, which you could write as 225 over x to the 4th also. If we distributed first, so we have 15x to the negative second squared. If we distributed first, we still get the 15 squared, but what happens when we have a negative power? Do you still multiply? Yeah. And what do you get? Negative 4, right? 15 squared x to the negative 4th, which because that negative exponent, we're not done yet, meaning we have to move it to the other part of the fraction, and lo and behold, we get the same answer that we got by just doing it first. 15 squared over x to the positive 4th. So when we start to combine these multiple rules here, it doesn't matter what you do first. As long as you do it, you'll be fine. Okay. I also want to take a look at the last one. How can we make our lives a little bit easier here? This is where we finally say, I advise you to simplify what you can inside parentheses first. How can we make our lives a little bit easier with that last one there? Will? Bring it down, and that leaves us with a 3 in our numerator. What does our denominator become? I heard it. 2n in the 5th, right? Because if we already have 2 n's in the denominator, we bring 3 more down. Essentially, our denominator becomes, 2n squared times n to the positive 3rd, which our rule for that, add the powers, that's where positive 5 comes from there. So it makes our lives a little bit easier in the sense that now we only have, one n term to deal with rather than two of them. Okay? We're squaring this. And so giving it to everything inside of our parentheses, we can write that as 9 or 3 squared. Either way is fine. Our denominator, give it to the 2, which we can write as 4 or 2 squared. Either way is fine. And when we give it to the n to the 5th, multiply those powers, n to the 10th is our final answer. Had we distributed first before moving that negative power down, we would have gotten 3 squared n to the negative 6th over 2 squared n to the positive 4th. And hopefully you can see that when we would bring that negative exponent down then, we would still get n to the 10th as a final answer because those negative 6 would be positive 6, and then 4 plus 6 gives us the 10. Either way is fine. Either way is fine. Okay, I feel like I've talked a lot. Any questions that you have or whatever, comments, complaints, compliments. Blake.
Good job.
Thanks. You too. Concerns. Congratulations. Criticisms. Apologies. No? Okay.
I'm sorry for liking you.
All right. The second page is look at all you get to do. Oh boy. The goal here is to not have to write the expression in expanded form. Use the rule to make your life easier. Any of these first 6 here, kind of the 6 that are easily writable on, that you want to talk about? Yes, sir.
I have a quick question.
Yeah.
If something's like if a is to the 0th power, would it just cancel out? All right.
Yeah. And if you have, is there a 0 power here easily at the bottom? Yeah. If you're distributing into something with a 0 power, I'm just going to write this here. Say you have, 7, a to the 0, x to the 4th to the 12th power, we'll just say. When you distribute that 12 in, it goes to the 7, so you get 7 to the 12th. And then our rule for distributing is powers are multiplied. What's 0 times 12? 0. So you still end up with a to the 0, which is equal to 1, so it doesn't really matter. And so, yeah. So even following this rule, it still all fits together, still all works. So anything from these, anything from these 6 that you want to talk about? It makes perfect sense. Okay. What about the next 6? I mean, surely you want about the last one, right? That's okay. I was going to say if we didn't get anything for the last one, that just wouldn't be normal. So this is another example where you have the opportunity to simplify within the parentheses first. Okay. In some cases to make your life easier. In some cases because you have to do it eventually anyway. But looking at our basis of x, right? I'm just going to rewrite this. I'm going to keep my 5 on the outside. Let's simplify first. Our basis of x, how can we simplify x to the 6th over x cubed? Peter. Okay, so where are our x's and how many do we have? Okay, because we had more there to start with, right? And like you said, 6 minus 3 equals 3. Anything we can do with the base of y there? Caleb?
You have to bring it down to the other side.
Okay, bring it down to the denominator, make it positive. Again, we're going to have to do all this eventually anyway. So whether you do it first or second doesn't really matter. And how about our base of z? Z squared over z. Peter. And we're left with 1z in our numerator. Okay. So simplifying first, it makes the numbers a little bit smaller. We take care of that negative exponent. Now we can distribute. And so our 5 goes into our x cubed. Powers get multiplied. We get x to the 15th. 5 goes into the z. It has a power of 1. Technically, 1 times 5 is z to the 5th. It takes it on anyway, being a variable base. And then our y's, 5 times 4 is 20. And so y to the 20th in the denominator. If you distributed first, you'd get the same answer in the end anyway, after simplifying. So it doesn't matter what comes first, but there you have it. There you have it. Any others? Blake? Sure, why not? So here you've got this negative exponent on the outside, which it's going to change the sign of everything in the parentheses anyway. So it wouldn't really be worth it here to move stuff around because they're just going to have to move it around again later on. Because any exponent that's positive in the parentheses, when you distribute, it's going to become negative. Any exponents that is negative is going to become positive because you're multiplying by a -2. So let's just do nothing. We can get rid of this a to the 0. We already talked about why there. 0 times anything is still 0. But 5 to the -2nd, it takes on that exponent. B to the -7th times -2 becomes b to the +14th. So if you did move that down first, you just finally have to move it back up anyway. So like I said, it kind of doesn't make any sense to move things until we're all done. And then c to the -20th. Now we can move stuff. Our b to the 14th stays up top because it's positive. Our 5 to the -2nd goes to the denominator, becomes 5 to the +2nd, which you can write as 25 if you want to. And then c to the +20th there. Okay? Any others? All right, you have about 12 glorious minutes to work. Today is Tuesday. Khan Academy is due on Thursday. The Week 4 Pick'em Challenge with a bonus prize if you go a perfect 16 for 16 has been posted as well. You can find that in Google Classroom. Current standings are also posted through week 3. This is due tomorrow, folks. That's how you math.